Hello everyone, welcome back to the YouTube channel Devotion of Knowledge. Today we are back again with another interesting video. And in this video we are going to discuss about a very interesting and very important C++ STL container or data structure you can say, which is set data structure. As I told you in the previous video, as soon as we start progressing in the playlist, the topics that we will be studying will get more and more interesting because in the last video we studied iterators, which was a very interesting topic. And in this video, we are going to understand about set, which is excellent topic we can say. So till now we have studied about vector. Excuse me, guys. Till now we have studied about vector, vector of pairs, sorting function, iterators, and etc. All these things we have already studied up till now in the playlist. But in this video, we are going to start with the set container. Now, believe me, set is very widely used container as far as problem solving is concerned, competitive programming is concerned, means the data structure algorithms, wherever are going to practice questions. Set data structure is going to be used very widely there. Now, why means what is that particular characteristic due to which set data structure is widely used? So mainly there are two to three characteristics of set data structure which makes it very useful. First one is that it stores unique elements. In vector, you can insert one into the vector five times. Means it is possible to have vectors having all the elements one in its data. But as far as set is concerned, no matter how much times we insert one will be always stored once only. Means there won't be any redundant element in the set data structure. Next characteristic is it stores data in sorted form. Set data structure sorts the data, stores the data in sorted form. For example, when you are creating a set data structure, for example, 1, 2, 3, 4, 9, 10 means you are inserting elements in random order, but the data that will be stored in the set data structure will be sorted 1, 2, 3, 4, and dot dot dot. These are the two main characteristics which makes set data structure widely useful. But another thing which is time complexity. What is the time complexity? Because whenever sorting comes into the picture, we have to carefully keep the parameter of time complexity as well into the picture. So whenever you insert the element, it takes log n time complexity, where n is the number of currently present element into the set. Into set. To fetch or to access the data, log n time complexity as well. And to delete the data, log n time complexity. Now you guys might have a question in your mind. Why only log n time complexity? Why log n? This might be a question in your mind. Those who are following this playlist from start or beginning, they would be knowing that I have mentioned a couple of times that set data structure, map data structure, they use red, black, tree for the storing of the data. Now, what are red black trees? How many of you are aware about binary search tree? BST. Many of you would be aware about BST. Now, red black tree is a self balancing binary search tree. Just remember this particular thing. We are not going to into detail red black tree because red black tree in itself is a good topic for discussion around 1 or 2 hours because you will study in upcoming semesters in the subject of design and analysis of algorithm. So red black tree is nothing but it's a self-balancing binary tree. Self-balancing binary search tree. Sorry, leave it. We are not interested in this. Just keep in mind that red black tree is a kind of binary search tree. So binary search tree follows the rule: if the value is x, it will store all the values on its left which are less than x, and it will store all the values which are greater than x on the right side. Right side greater than x. So it will be more or less a kind of binary search because, for example, if it is like this 3 less than on the left side, greater than on the right side, 5 uh, less than 5, for example, 4 greater than 5, for example, 7, 1. So if you are willing to find 7, initially we will be standing on the root node, we will be standing here. Now we want to find 7. So 7 is greater than 3, okay, so we will be just searching in this much part only. Now we will come here. We are searching for the 7. Is 7 greater than 5 or less than 5? Greater than 5. Okay. So we will be searching only in this much part. So now here we got 7. But if it was not there, then we will be just doing nothing. We will be just dividing a particular given tree or data into half. So I think those who are aware about binary search, it is log n time complexity. So that's why insertion also takes log n time complexity. Fetching the data also takes log n because in terms of insertion, for example, I want to insert 8. First of all, to insert 8, I should find a correct position. Where should I be inserting 8? So I would be coming up to 7, and on right hand side of 7, I will be inserting 8. So that's why. And for deleting as well, we should be having that particular element in the tree first. Then only we can delete that particular element. So these are also one of the very important parameters which makes set data structure very useful. So first of all, it only stores unique elements. You won't be having more than a similar element more than once in a set data structure. Second one, it stores the data in sorted form, means in ascending order, means 1, 2, 3, means in increasing fashion. Next thing which makes it very useful is time complexity. It takes log n time complexity for each and every operation, where n are the currently present elements into the set. And why log n time complexity? We also understood the reason. Here is it, because it uses binary search tree, means red black tree, which is a self-balancing binary search tree. And I think I explained you enough to understand that why log n time complexity is there, because red black tree, it's a very vast topic in itself. So we are not going into much depth of it, but I think this much is enough for understanding set. Now, set data structure also has many types. One is normal set. All the characteristics that we understood right now were of a set data structure. Next is multi-set. In multi-set, this property is not followed. Similar element can be present more than once in multi-set. So this property is not followed in multi-set. Data will be in sorted form, but more than one element can be present similarly. Means redundant elements are possible. Third one is unordered set. The fourth one is ordered set. We will be understanding unordered set and ordered set in the next in upcoming videos. How unordered set and ordered set are different from these two. Right now, let me give you an idea about unordered set. And ordered set, we are going to understand it in dedicated next video. So we are not discussing it right now. In unordered set, the second property is not followed, which is data is not stored in sorted form. Let me repeat. Data is not stored in sorted form. Okay, recording is still going on. Let me repeat. Data is not stored in sorted form, but Another set, its USP is means unique selling point means what is a signature or a very important thing which makes it different from other containers. It is it can fetch data in constant time complexity. Means in this tree we can have 7 rather than O of log n time. We can fetch the data in O of 1 means constant time complexity. But in not in every case, in such cases, amortized analysis come into the picture. Amortized analysis means if I perform 100 fetch operations on unordered set, then by taking average of each and every operation, we will get constant. Because in sometimes it will be also taking O of n. In some it will be taking less than constant. So on an average, it is working in constant time complexity, which is O of 1. But why? Because it is not completely based on red black tree. It uses hash table in backend to implement its functionality, due to which it is not storing the data in sorted form, but it is mainly used when we are supposed to fetch large amount of data. So there another set comes into the picture because it has a very good characteristic of fetching the data in of one time complexity. Okay, so I think it is enough for us to understand about a set data structure. But as I say in every video, rather than understanding the concept is equally important, but writing the code or implementing that particular container is even more important than understanding all these concepts. So let us directly move in writing the code or how to implement a set data structure. Uh, and yeah, we are also going to solve one problem in the video, which is of code forces. Okay. Or I think we can also solve this problem in the next video because I am not much aware about the length of the video. It is already 12 minutes, so I don't think we'll be solving the problem in this video because otherwise the length of the problem will be too much. So let us directly move for implementing the set data structure. This is my code snippet. Let us remove it. Now, what is the syntax for initializing set data structure? First of all, write set data type and name. It is the syntax for understanding or for initializing set data structure. Okay, so we'll be writing set. What kind of data we want to insert? I want to insert set or integer, and let us give name as s. I want to insert for int I equal to 0, I less than. Suppose I want to insert 10 elements, I plus plus. To insert element or to fill or insert some element into set, we write s dot insert I. Whether in vector, we will be writing pushback. Here we write s dot insert. And now, as I told you, set and hashmap are not linear data structures. So we have to use iterators for accessing the elements of the set data structure or a map data structure that we will study in future. So let us write what is the data structure? Set int iterator it equal to s dot begin. Let's write for loop. We have already initialized it, so no need for writing that condition. It is not equal to s dot end and it plus plus. So we'll be just counting or printing star it. Let us run the code. Yeah, output is there 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, as I told you, it stores data in sorted form. So here, as you can see, data is already in sorted form. Now you think we are inserting data into the sorted form. No worries. greater than equal to 0. Here we are inserting data in reverse manner from 10 to 0. Then also, as you can see, output is still in sorted form. Now, let me insert suppose 5 multiple times. But then only you can see 5 will be only displayed once because see, I am inserting here 5 multiple times. But as I told you, set only stores unique elements. That's why 5 is only once in this data structure. Or we are printing, so 5 is only displayed once. So I think this much is enough for understanding set data structure. Mainly this 2, 3 stores unique elements. One is this, another one is sorted form, and very important, time complexity. In next video, we'll be solving one problem on set data structure. Means it's a relatively easier problem, but it is more advisable to solve some basic problems after immediately after understanding the data structure, so that we can get conceptually as well as syntactically more sound in using a particular data structure. Similarly, we will be also doing into the map. We didn't perform this thing in our previous videos because vectors or pair were not that much difficult data structure to understand or to implement, because there we were already able to access the data without using iterators and all that. But here in set and the map data structure that we'll be understanding, it uses many functionalities such as iterators, means sorted data and unique elements and all that. In map, we'll be having key and value pair as well. So whenever such kind of data structure comes into the picture, it is more advisable or preferable to solve the problems, basic problems. No worries, because unless and until we don't take a stepping stone, we won't be able to solve some advanced problems or some good problems. So in the next video, we will be going through one code forces problem. It's a basic 800 rating problem. And those who want to try, the problem name is pangram. No worry, we will be trying it in the next video. We'll be dedicatedly solving that problem in the next video. From scratch, we'll be understanding the problem, coding as well. So no worries. Till then, just keep learning. We'll meet in the next video. I hope this set data structure I make you interesting to learn. I make a video a bit interesting so that you guys can learn. Till then, we'll meet in the next video. Keep learning, keep hardworking. Thank you.